Okay, so we have 5, 5, 5, 6. We're taking these two sections and actually combining them. You won't even notice the difference when I combine them. But we're going to do part of it today. We're going to do an activity tomorrow over what we're doing today. We're going to finish it Wednesday. Tomorrow's Wednesday. Cole messed me up with the dates. So tomorrow, Wednesday, we're going to do an activity. Thursday, we're going to learn the second. Stop speaking. Tomorrow is Wednesday. Then Thursday, we're going to finish this section. Stop it. And then we're going to have an activity Friday. Your quiz/test, it's really more of a quiz, over the last part of this chapter will be on Monday. On Monday. I normally don't. However, it's going to be a lot shorter of a thing. So Friday, your homework will be your review. We'll spend the first half of class reviewing Monday. No, definitely did not. No. All right. Right? All right, so here we go, guys. The fundamental theorem of algebra. You actually already know this. I've taught this to you guys a long, long time ago. Pretty much in a nutshell. Might be hard to see this. This is x cubed plus 5x squared plus 4x plus 20 equals 0. How many answers does this have? 3. Hey, there you go. That's the fundamental theorem of algebra. Hey. Already taught that to you. This one is an x to the 4th. How many answers does it have? 4. Good job. Nice job. All right, moving on. All right, so what does it mean when the graph looks like that? Good. Even. So it's either like x squared, x to the 4th, x to the 6th, something like that. I'm impressed you guys remember that. Negative. Very nice, because we know it's pointing down. What do we know about the answers?
There's only 2. Wait.
There's an even number of them. Probably 2, but it could be 4. Good. It is second degree. What do you know what one of the answers is just by looking at the picture?
1.
Good. We know that x equals 1 because it touched at 1, right? Did you know that x equals 1 actually shows up twice? That's an answer twice. How do you think I know that?
1, 1.
Right, but why? Normally, when we look at things and we graph them, if I did something like this and I asked you what the answers were, you would tell me wherever it crossed here, here, and here, right? You look at where it's crossing. This only went up. Did it actually cross the x-axis? It kind of like bounced off of it and came back. If it bounces, it's a really technical term there, bounces. If it bounces off of the x-axis, wherever it touches, that answer shows up twice, or 4 times, or 6 times, or 8 times. Chances are it's probably just twice, could be 4, but so if it bounces, if the graph bounces, technical term there, off the x-axis, the answer appears technically an even number of times. So 2, 4, 6, 8, blah, blah, blah. What? So if it goes through the graph, through the x-axis, like this one here that I drew, that answer technically shows up in odd number of times. Usually it's once, but it could be 3 times. Something to just kind of keep in mind as you're looking at the graphs. Like the one I hand drew up here, this one, if the graph actually goes through the x-axis, then that answer shows up an odd number of times. Typically it's once, but it could actually be like 3 times. That's what we're going to talk about today. He did, like, how are we supposed to know? Like he's going to cry. Cool. I don't know. I don't think they've ordered them yet. Probably not. Well, then you'll all have to come back after break and come sit on them. You still can, yeah. You could still sign up for my help sessions to come in here and hang out with me. Noah?
Can you ask Mr. Cook when he gets a chance if we can borrow her phone?
We'll see. All right, guys. So the problem we have is factoring some polynomials can be difficult, right? Sometimes it's hard to factor things. Because does it always factor? No, not everything factors. That's an issue. So what we did before break, like that last day before break, we did like the turkey thing around here, right? I gave you, I know it was really long. I gave you, Miss McCourt made it, you can yell at her. I gave you guys one of the factors, right? I told you either x equals 5 or one of the factors is like x plus 5, something like that. And you were able to use synthetic, and then you were able to go from there. Same idea today, but I'm not giving you anything. Aren't I nice? Taking the training wheels off. I'm not giving you anything. Yeah, I'm not giving you anything. So here's the problem solving. Oh, no, no. Let me explain. This is not too bad today, guys. So you'll find one of the factors. You will find it yourself. And you'll use it to break the function down using synthetic division again. And no, we're actually going to solve today. We're going to find all the answers. Okay? There is a way to do this by hand. And I will kind of show you quickly an idea of what it looks like after I show you the technology piece of it. But let's be honest, the day and age we live in, we're going to use technology. Okay? But you can do this by hand. All right. So I want you to find all of the rational zeros of that. X to the fourth minus x cubed plus x squared minus 3x minus 6. If I give you this problem, do you have a way of factoring that? It has 5 terms. We do factoring with 4 terms, but no, we can't factor this. We have no idea how to factor this. So step by step how this is going to work. First thing we're going to do is we're going to graph this. Okay? We're going to graph it. We're going to look at that graph and find the nice zeros or the nice answers, the nice places it crosses the x-axis. Right? Remember, zeros just means your answers, your solutions, right? Then we're going to use synthetic division with those to get it down to at least probably a quadratic. That's what we like to aim for, so we can get it down so we can do something to factor it from there or solve it by quadratic formula. So we're going to go ahead and graph this. So in the graphing calculator, do you remember how to graph things? Good. Hit the y equals button. All right, let's go ahead and type in that equation. If I can find it. All right, so do you guys remember how to type all this stuff in? X to the fourth minus x cubed plus x squared. It is clicking. It's driving me nuts. Minus 3x minus 6. I'll fix it later. All right, and then go ahead and hit graph. Can you tell it's not an x squared just by looking at it? It's just a little off, right? Off. Just a little bit. Yep, so type it in and hit graph. Very nice. Now looking at the graph, where do I think it's crossing the axis? You think it crossed at 0? -1. Always the x-axis. It looks like -1 and 2. How do I confirm whether that's really where it's at? Look at your table. So hit second graph. It pulls up your table function. No, definitely not. That's your table set. Just hit second graph again. All right, you guys said you thought it was -1 and 2. So if I look at my table at -1, it's 0. And at 2, 0. So those are good answers. Those are my zeros, right? So -1 and 2. Any questions on how I just used the calculator there? All right, let's go back to the problem then. So I'll make myself a little note. I know that x equals -1 and 2. I know that for a fact. So now we want to actually use synthetic division. Okay, so setting up synthetic. Remember 1, -1, 1, -3, -6. What am I dividing by? negative 1, and then 2. Right? Remember, this is x equals. Actually use what it equals. We don't switch those ones. So it doesn't matter which one you use first. I'm going to go ahead and use negative 1 first, only because that's the first thing I have written down. Okay? So looking here, using our synthetic, if we multiply, we get negative 1, add, negative 2, multiply, 2, add, 3, multiply, negative 3, add, multiply, 6, add, 0. Should I get 0 for a remainder? Yes. If we looked and those are answers, there shouldn't be a remainder because it's a factor. All right, now this problem started x to the 4th, so this is now x to the 3rd. Because I have another answer I can use. Let's get this thing down to an x squared so then I can factor it and finish solving. Okay? I'm going to go down and do synthetic again, and now this time I'm going to use the 2. Sorry. All right, so let's drop my new numbers down, and let's do synthetic again. So multiply, add, multiply, add, multiply, add, and I'm very happy about that, right? All right, we started x to the 4th. I did synthetic twice, so I'm down to x squared. So let's fill this in. I have x squared plus 0x plus 3. So really I have x squared plus 3 equals 0. Because I need to either factor it or solve it in some other manner. Does this factor, or can I just solve this? I can just solve this. Right? So x squared equals negative 3. Right? Subtract the 3 to the other side. Square root, good. This come back to you after break. That's good. Plus minus. Oh, good. We didn't forget everything. So, how many answers should this problem have? 4. It should have 4 answers. Do I have 4 answers? Yes. Here's negative 1, 2, a positive I radical 3, and a negative I radical 3. Why could I not see the I radical 3 on my graph? It's imaginary. What's it mean if it's imaginary? Okay? Doesn't exist. It exists. It's just not real. It does. It's right.
Yeah, name something that doesn't exist that's real other than that. Like a unicorn. No. What the heck? But the thought of unicorns are real.
Thank you. Appreciate that. All right, guys, time out. That's not what I was talking about. Time out. If a number is imaginary, that means it does not cross the x-axis. That's what those mean. We'll hold that deep conversation for another time. All right, so let's look at the next one. Let's look at the next one. So, finding the zeros, this thing's huge. How many answers will we have? 4. X to the 4th is the highest thing we got going on there. So again, grab your graphing calculator. I have no way of factoring that. So let's use the graphing calculator. And let's go ahead and graph it. So back to y equals, clear out what you got, and let's type in this one. Do me a favor, guys. Please double check what you typed in before you hit graph. Because it's real easy to accidentally hit, the wrong number or the wrong sign, or you forgot the x and put an exponent or whatnot. Because otherwise it looks really awkward. Yes, sir. You have to hit the caret button. And then you have to hit the arrow then to kind of push that cursor back down. There you go. You're welcome.
You hear that? Do you hear that? Still does not exist, therefore is not. Yeah, but the thought of Santa Claus
still there. We all sleep in Santa, but yet he's not real. We're never
But he was there. Before Santa ate them cookies.
So it's imaginary.
No, your dad ate those cookies. Actually, yeah, he did.
Time out. Time out. We need to get through this, guys. All right, so that's what that graph looks like. So what answers can we see that we think or we know are there? -2, and where do you think that other one is?
1.5, yeah.
Maybe a half? What else could it maybe be? Maybe a quarter, a third, something like that. I'm not entirely certain.
460.
Let's look at the table, see what happens. So if I look at the table, the -2 was good, right? -2 is a 0. That one worked. The other one, it's not imaginary because it crossed. It's just not a pretty number. Could be a fraction. Could be a radical. Not entirely certain.
But you gotta guess and check.
When you do it by hand, yes, it's guess and check. But am I going to let you use the graphing calculator?
You are gonna let us.
I am. All right, so we know -2 is a good answer, right? Kind of keep that in the back of your mind. We're going to need to know that. Go back to your graph. Hit graph again. I don't know. So go back to your graph. We know -2 works. The other one, I can guess it's maybe like a third, a fourth, a half, somewhere in there. I can find out. Okay? So if I hit second trace, that brings up that calculating menu again. Now, we've used this button before. What do you think we want to calculate?
0.
The 0. I want to know the zeros. So I want to choose option 2. Now, your calculator is going to do the whole crazy left-bound, right-bound thing again, but I need to caution you. Because it's going left-bound, right-bound, it really wants below the x-axis and above the x-axis. Okay? One has to be below that 0, one has to be above the 0. So when it says left and right, it kind of depends on what your graph looks like. I can't really tell you which one's below and which one's above. You have to look at it and tell. We read from left to right, though. So when I'm looking at this graph from left to right and I'm drawing this, I'm trying to find this point. Is left bound going to be below or above it? Below. So right now my cursor is below. I'm going to hit enter. And it's going to ask for right bound. So is right below or above?
Above.
It's actually above. So I'm going to move it somewhere above and hit enter. You want to guess?
1/4.
Hit enter. It tells me it's 0.3 repeating. What's 0.3? That's 1/3.
Shoot. What? You boy.
It's 1/3. All right, so we can see that it is 1/3. Now, if you're like, I don't know if I really like the graphing calculator to do all those steps, could you use synthetic and figure it out? What should be the remainder if it is a factor? The remainder should always be 0. There shouldn't be a remainder. So could you guess half and do synthetic and see if you get 0 for remainder? Could I guess it's 1/3, do synthetic? Yeah, you really could. Is it the fastest? Not necessarily. But if you're not comfortable with the calculator, you could do that. All right, so let's go back here. So we know that x equals, what did we say, -2, and we found out it was 1/3. So let's go ahead and set up our synthetic. So 3, 17, 30, 12, -8. Ooh, got some big numbers in there. Do the what? The 1/3? I'm fine with that. Do you guys know 1/3? I'm just dividing everything by 3, right? Until you multiply by 1/3, just divide by 3. Well, I know some of you are like, oh my gosh, 1/3 times 3. I have no idea. It's divide by 3. So what's 1/3 times 3? Is 1.
Shoot.
Add 1/3 of 18 is 6. Add 1/3 of 36. Add 1/3 of 24. 8. Add 0. 0. All right. So I started x to the 4th. I'm down to x cubed. But I have another answer to take this down to an x squared so I can actually solve this thing. So now we're going to use the -2. And we're going to go again. multiply. Add. Multiply. Add. Good. I'm done. All right, so I used the answers I found. 1/3, -2, those are good answers. This is now 3x squared plus 12x plus 12 equals 0. All right, you have some options here. I'm down to an x squared. What's the fastest way to solve something? Factoring is really the fastest. If, I hope at this point this is not the case, but if you still can't factor, the quadratic formula would work. However, if you can't factor in the next chapter, you are in serious trouble. All right, how do I factor this? What's the first thing you want to do?
3 is common factor. 1 and 3.
Take out a 3. GCF, Noah. I throw those ping pong balls at your head.
Squared
So we have x squared.
plus 4.
Thank you for that. All right, so here, let's factor this further. What are your signs? Plus and plus. Options for A. See? It's going to be the 2 and 2. So x equals -2, -2. And then we also had -2 and 1/3. What did we talk about those answers that show up? If it crossed through the axis, that answer shows up an odd number of times. So we assumed -2 only showed up once, but it actually showed up 3 times. Do you have any way of knowing that before you get started? No. We don't know. It'd be nice if we did. We'd be done real fast.
Those cutout worksheets is going to make it easier, because if we have like 3 of one answer and you mark it wrong, then we know to do 3 of the other.
Or they could all be different answers. Oh yeah, that right there. All right, find all the zeros. How many answers am I going to have? 5 answers. What do I do first? What do I do first? Graph it. Let's graph this. Oh, come on. You can graph. You guys are not that slow.
That slow?
You're not that slow is what I said. You guys know how to do this. So let's graph this. You, yes. Stop it. All right. X to the 5th. Or x to the 4th. Guys, make sure you're typing these in and practicing as well. This is going to be all you on your test on Monday.
You're going too fast.
It's in front of you. Plus, it is still on my board. You can still see it.
Hey.
What the heck?
Again, if your graph doesn't look like that, hit y equals, look at what you typed in. You probably forgot an x. Whoa.
Uh-oh.
You have x to the 5th being multiplied by a negative. You typed in the wrong buttons. No, you won't need parentheses. Like I saw you put. No, no, it doesn't. It doesn't. Yeah, you did. No, you don't. His belt just fell off.
That's not a fire.
That's not a fire truck. That's an EMS.
There's fire truck. Why is it coming here?
Wait, there's one.
That is a equipment.
Damon,
Yeah.
you didn't type it into y equals.
Oh my gosh.
74, no.
Fun answer.
That's your family?
I love fire trucks.
All right, guys, come on. All right, so take a look Where does it cross the x-axis?
-1 and 2.
How many times does -1 show up?
Twice. More than
Probably twice. At least 2, maybe
4.
maybe 4, but at least twice. Right? Because it looks like it bounces.
It balances.
All right, let's double check the table. Second graph.
Yeah.
So -1 is good, 2 is good, right? So if we go back to here, we know x equals negative, was it -1 and 2? I just now forgot what I said. Okay. All right, we know -1 actually shows up twice because it bounced off of it. Yippers. All right, so let's take a look, see what happens here. No. So let's go ahead and set up our synthetic. It bounced off of that point on the graph.
Wait, can't we just like do
Flip the signs.
like if we do -1 with all
Let's. No, it doesn't just flip the signs. Let's do -1. We'll see what happens. Oops, that should not be negative. Sorry, that's +1. It doesn't work. It doesn't. All right, so here we go. So I drop this down, so we multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. All right, so right now, I started x to the 5th. Right now, I'm down to x to the 4th. That shouldn't have been a trick question. All right. So let's do synthetic again. Do you want to go with the 2 or the -1 again? -1? Because we know it shows up twice, so that means you have to use it twice. Okay, so let's go through our synthetic process.
See, the signs change,
The numbers change too.
right?
All right, now what do I do? Synthetic again, let's use the 2. All right, so synthetic again with the 2. So we know all of these work. We confirmed it. There's 0 for remainders. I started x to the 5th. I did synthetic 3 times. I'm down to x squared. So we have 1x squared minus 4x plus 7 equals 0. Damon. Does that factor? Okay, this is not going to factor because what are your options for C? Is 1 and 7 ever going to make a 4? No. Okay, so this does not factor, but we do have the quadratic formula that we know will work, right? Thank you, Paul. All right, so -b would be, what's -b? 4. Plus or minus square root b squared, -4 squared, minus 4 times a c all over 2 times a, which is 1. All right, so x equals 4 plus or minus the square root of, is that -12? So let me check my math there. Nobody's checking me. You're just going to take me at my word.
Well, you are math. I very trust.
Thank you. But I've been off for a while. I get rusty. Thank you. Just want to confirm. All right. So we know that there's going to be an I in here. So 4 plus or minus, do you know how to simplify the radical 12?
Oh,
2i radical 3 all over 2. Good. So simplifying this gets us there. Divide all of them by 2. I radical 3. So there, how many answers is this? 2, 3, 4, 5. You got all 5 answers? Is it possible we can graph one of these and all of the answers show up on the graph? It's absolutely possible. So what happens when you get those ones? You write them all down. You get real excited. You move on. Sometimes it happens. Good. Good. All right. No, we're not doing all of this today. All right, so let's go ahead and take a look at this one. Go ahead and graph it. You graph it, I'll graph it. When you're, okay, good question. The question was, do you have to put the zeros in when you graph it? No. The graphing calculator is smart enough to realize things are missing. Synthetic, yes, but graphing, no.
Let me guess. What's the score?
No, I did. Say it's cute. I think she's referring to the graph. How many answers should this problem have?
Wow.
It should have 4. Do we have some nice ones on there? Yeah. What do we know x equals?
Negative one. Negative dose. I have a question.
So look at the or the table, just make sure. So negative 2 is good, 1 is good, 3 is good. Do you actually have all 4 answers?
Oh yeah. Negative
Did it bounce? It bounced right here.
So these are one of those things you just write down.
Yes! You didn't think I'd ever give it to you.
No, we're talking about. I have a question. I like that.
So x equals negative, was it negative 1? I totally lost my train of thought.
Negative 2.
It was a negative 2. Sorry, thank you.
Test and homework, please.
So negative 2, negative 2, 1, 3, is that what they were? Don't care. Nope, just the x-axis. Think about we're always solving for x, so it's where it's crossing x.
Oh wow.
Do I have to do any work? No. If I did synthetic, though, what should I always get for a remainder? Should always get 0. So if you want to check it, you could use synthetic, but do you have to? No, you don't have to. Okay, how about that one? Okay, you guys graph, I'll graph. Let's see what happens. Yep. On to the next. You know they never are. Can you? Yeah. I don't recommend it for this. But yes, in math, that is a thing. All right. How many answers does this problem have? Should have 4. How many do I see on my graph? I see 2. Negative 2 and 1. You guys good with that? So x equals negative 2 and 1. So I can see those. So what do I have to do? Tell me, what do I do? Let's use synthetic. So 1, 1, 2, 4, negative 8. Does it matter which one I use first? No, which one do you want to use first? Negative 2. Does not matter. You'll get the same answer regardless, so it doesn't matter. So go ahead and go through our synthetic process. So we know negative 2 works. You get 0 for a remainder. Then what do I do? Well, if you go run into it and it doesn't give you 0 for remainder, one of two things just happened. Either 1, you messed up your synthetic, or 2, it's really not an answer. So that happens. All right, so we use synthetic again with the 1. So 1, 0, 0, 4, 4, 0. So we know 1 works. What do you have left at this point? Try again. Yeah. Because this is x to the 4th. I did synthetic twice and down to x squared plus 0x plus 4. So really it's just x squared plus 4. Yeah. Difference of squares implies which sign? Difference has to be minus sign. So this, no. So x squared equals negative 4 square root. There's no bx term, so we can just solve it. So what does x equal? Good. Plus or minus 2i, negative 2, and 1. So, guys, when you're looking at your graph, and we saw that it only crossed twice, then that usually means your other two answers are going to be imaginary, right? Because you can't see them cross the x-axis, so they have to be imaginary. All right, what do we got? 1 left to go? 1 left. Here we go. All right, here we go. Last one. Let's go ahead and type it in. Let's see what happens. Because you're not erring over off of your exponent. Because I'm smart. Are you impressed that I knew without you even asking? I'm kind of insulted that you actually doubting me at this point in the year. No, it wasn't my math skills. On my math skills, not on knowing what students are having issues with. There are zeros. Because looking at, are there any nice ones? Mm-mm. Now, looking at this, it does bounce. What do you think it bounces off of? It looks like negative half. So negative half probably shows up twice. What about those other ones? Do they look like you might know what they are? They're a little off. Let's do the whole calculate thing. I just want to show you something. Okay? I want to show you what happens here. So let's go ahead and hit second trace. And I want to calculate the zeros. Now, left bound, right bound, I'm going to go ahead and calculate this first one right here. In the it looks like negative 1 3/4 kind of ish. So left bound from this one, is it above or below? Above. So arrow to the left. How do you know that that's above? Think we read from left to right. So like as I'm drawing this thing from left to right, as I'm starting it, to the left of it, starting from the left, is actually above. Then as I keep going beyond, it's going to be below. The good thing with the calculator, if you mix up which one's above and below, it's going to give you an error. So then you're like, oh, I just messed up which one was above and below. All right, so left bound, enter. Right bound then is going to be below. I don't want to guess. Yep, second trace brings up your calculate menu. Negative 1.732051. My experience with numbers, I know what that is, but I'm betting most of you don't know what that is. It means you've messed up your left and right. You're the one who said you didn't get it either, Trey. Don't make fun. So is that a nice fraction that you recognize? No, it's not. So what happens is this right here, it is a real number, but it's a radical. Radicals are decimals that don't ever repeat at all. So looking at that, again, I have enough number sense knowledge and I recognize what radical that is. I'm betting you don't. So, yeah. So which one do we know did show up, though? We know for a fact, or we at least assume pretty closely, that this is negative half. Let's try. So we think x equals negative half twice because it bounced. So let's try it. What's the worst that happens? I go through my synthetic and I don't get 0? Just means it didn't work. All right, so let's set up our synthetic. All right, so what is negative half of 4? Negative 2. Add 2. Negative half of 2 gives me negative 12. Negative half of negative 12 gives me negative 6. Negative half of negative 6. So is negative half a good answer? Yes, it is. All right, so we know that negative half actually shows up twice because it bounced at that point. So let's do negative half again. So negative half of 4. Negative 2. You guys alive? Where'd you go, Damon? That's 0. What's negative half of 0? Negative half of negative 12? That's 0. So we started x to the 4th. I did synthetic twice. I'm down to x squared. So I have 4x squared plus 0x minus 12. So really I have 4x squared minus 12. Good. So x squared equals, 4x squared equals 12. Divide by 4. So x squared equals 3. Square root. X equals plus or minus radical 3. Negative half and negative half. So that negative 1.7 blah, 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 whatever that was, that's radical 3. Grab your calculator real quick. I want you to see this because I don't think you guys always put together that radicals are actually numbers. If you hit second quit, second mode right next to there, takes you back to your regular calculator screen. Type in square root of 3. Because what it's asking you is what number times itself gives you 3. Your calculator, though, if I do the whole finding the 0 on the calculator and I get that 1.732 blah, 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 if I type that in and try to switch it, your calculator won't switch it for you. Because it's irrational, which means the decimals keep going forever and ever and ever and there's no pattern, so it doesn't know when you stop typing in those decimal numbers, it stops calculating and it's like, hey, I can't turn that into a fraction. It doesn't understand. But I want you guys to recognize, because I don't know if you guys always make the connection that looking at something like this, the 1.732 blah, 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 that is the square root of 3. Because you think about, okay, 1 times 1 is 2 times 2 is 4. So I passed the 3. So obviously somewhere between 1 and 2 is the square root of 3. It's got to be a number somewhere in between there. Okay. So we have all our beautiful answers. Questions on all of this and how this works? Doing okay? All right.